Alright, here's another example of finding the area of the equilateral triangle with the radius given being 3 meters now. And recall that the equilateral triangle is a type of triangle that has all three sides being equal to each other and all three angles are the same. So these three angles are going to be 60, 60, and 60 degree. The difference between the form of the area of the equilateral triangle when the radius is given versus the one when the side is given is that in this radius form you have the additional number 3 here versus when you are given the side or the perimeter, the format or the version of this formula, it's just going to be 1 times square root of 3 over 4 times the side square, and you have 3 times square root of 3 over 4 times the radius square. But the way you do it is very similar to each other. Remember that the radius only goes with the circle, so how do we come up with the radius that goes with this triangle? Well, we had to put it inside a circle, of course, so that's what I did, and we had to note the center. Now, the radius, by its definition, is the distance between the center of the circle all the way to the edge of the circle. So all the way to here, here, or there. But we cannot just go from this center and go to any place that we randomly select. We have to go to a specific spot, and that specific spot has to be where the vertex of the triangle and the circle intersect each other. So we can go from the center to here, or to there. So I'm just going to go from here to here. So this is the radius, denoted by 3 meters. So that's the pictorial representation of that. But since we know the radius, just replace this with 3 meters. So we get 3 times square root of 3 over 4 times 3 square. Well, mental math, we know for sure that 3 squared is 9. 9 times 3 is 27. So this is 27 times square root of 3 over 4 meters square. So this is the answer of the area of this equilateral triangle using this formula. Now, what if we were to use the formula for the area of any type of triangle, which is 1/2 times base times height? Well, to find the height of this triangle, of course, we have to cut it out into something like this. We cut this entire triangle into 2 halves, starting from the top vertex and perpendicularly all the way down to when this dashed line intersect with the base, perpendicularly, forming the right angle right there. So using this triangle here, and of course I can always, I can always sketch another radius here. This is going to be 3 centimeters, and this is going to be 3 centimeters. So, oops, 3 meters. So I can take this triangle, this one, or this one, and I can find this base, because this base is the same as this one. Okay, so I can pick any of that. Well, let's just say I'm going to pick this one down here. So by picking this triangle down here, let's see, this is the dash line, the right angle is here, the right angle is here. Now over here at this angle, this is 60 degrees, but because this radius bisected, we know this half, which is this one, is 30 degrees, and this other half is also 30 degrees. And same thing for this one. This angle 60 degrees got bisected. So that means this half, which is this one, is 30 degrees. And this other half is 30 degrees as well. And this is 3 meters, and this is 3 meters. Well, if this is 30 and this is 30, of course, this whole thing here has to be, let's say I'll put it 120 degrees. Because remember that all angles of any triangle has to add up to 180 degrees. To find the base, to find this base here, I'm going to call it letter S. We can use something called the Law of Sine. So we can say by the Law of Sine, we can set up two ratio being equal to each other. So when two ratios equal to each other, we call that a proportion. To set up this proportion, we can take any one of the known sides and set it over to the sine function of the angle that is respectively opposite to that known side. And we set it equal to another ratio, but that other ratio is going to include the unknown side, which is the base, divided by the sine function of the angle that is opposite to that base, which is 120. So I can pick this or this. So really, I technically have 3 over sine of 30. Hopefully you can see that. And equal to the base s divided by sine function of 120 degree. And from here, just algebra manipulation, right? You want to get s by itself, so of course multiply both sides by sine of 120. This will cancel each other out. So you're left with just 3 times sine of 120 degree over sine of 30 degree equal to s. But according to the unit circle, sine of 120 degree, I should say this, sine of 120 degree, according to the unit circle in trigonometry, is going to be equal to 2 pi over 3. So sine of 120 is the same as sine of 2 pi over 3 divided by sine of 30. But sine of 30 degree is sine of pi over 6. But this is going to give us 3 multiplied by sine of 2 pi over 3. And sine of 2 pi over 3 is actually square root of 3 over 2 divided by sine of pi over 6, which is just 1 over 2. Well, let's see, we have this denominator being the same as this one, so they cancel each other out. So we're left with just 3 times square root of 3. And this right here, meter, this is the base, equal to s. So s is 3 times square root of 3 meter, like that. So that means this right here is 3 square root of 3. This here is 3 square root of 3. And this here is also 3 square root of 3. So like that. Now that we find the base here, we know that the other two bases of the other two triangles is also the same value, because this is an equilateral triangle. We can take either this half or this half, and we just have to find the apothem using the 30, 60, 90 property. So let's say I'm just going to take the right half, which is the same as this one. So taking the right half, we have 30, we have 90, of course this is going to be 60, okay? So by the 30, 60, 90 property, opposite to 30 degrees is going to be the short leg denoted by x. Opposite to 60 degrees is going to be the long leg denoted by x times square root of 3. Opposite to 90 is going to be the equation denoted by 2 times the short leg x. But we know this hypotenuse here is 3 meters, like that. So that means we can set 2x equal to 3. So for x, that's going to give us x equal to 3 over 2. And this is called the apothem. So we're going to need that. Now with the apothem being known, we get to go ahead and use the formula for the area of any triangle, which is 1/2 times base times height. And we find the area of this triangle, which is going to be the same as this area of a triangle, which is the same as the area of this triangle. Because remember that these 3 triangles are the same. So if we find the area of one of them, we know that the area of the other 2 are going to be the same. So by adding the areas of all of these 3 triangles together, we're going to be able to find the area of the entire thing. So by the formula for the area of any triangle, 1/2 times base times height, so the area of 3 triangles is equals to 3 multiplied by 1/2, because we got 3 triangles here, multiplied by the base of their respective of each triangle. But the base of each of these triangles has the value of 3 square of 3, like this. So we got 1/2 multiply, we got 1/2 multiply the base, which is 3 square of 3, and multiply by the height of each of the triangle, which is 3/2. So that means we got 3 multiplied by, well, let's see, it's 1 times 3 square of 3 times 3. That's going to give us 9 square of 3 over 2 times 2, which is 4. And then 3 multiply this fraction is going to give us 27 times square of 3 over 4 meters square. So this is the area of this entire equilateral triangle. So that is by using the formula for the area of any triangle, 1/2 times base times height. But what about the formula for the area of any regular polygons? Well, we know that formula, area of reg poly, which is a regular polygon, is equal to 1/2 multiplied by the apothem, lowercase a, multiplied by the perimeter, capital P. But we know the apothem, which is this thing right here, is 3/2. So we got 1/2 multiplied by 3/2, multiplied by the perimeter. But the perimeter can be found by simply adding all 3 sides of this entire equilateral triangle together. So we got this plus this plus this. 3 square of 3 plus 3 square of 3 plus 3 square of 3. Like that. So this is going to be, let's see, 1 times 3 is 3, 2 times 2 is 4. So we get 3/4. Multiply, keeping the square of 3 the same, just add the coefficient. So that's going to be 9 times square root of 3. But hey, that's going to give us 27 square root of 3 over 4 meters square. So you see, 3 different formulas, but the same answer.